Hello, everybody. Thank you so much for having me here today to represent IBM Watson Health. What a great lineup of speakers, and it's incredible the amount of work that's going on in the industry and with metadata. So my talk today will be a little bit about data and its role with cognitive in improving health in the life sciences industry, in healthcare, and really around the entire healthcare spectrum. So just a little bit about myself. My name is Laila Rehan. I started my career at IBM as a sales executive, solutions architect, where I was selling and developing strategies for business development opportunities at pharma companies, medical device firms, and biotech firms. Since then, I've moved into a more enablement role. I'm a first-time mom of a 4-month-old, so traveling and getting on a plane every other day it wasn't the lifestyle I needed anymore. So now I'm working from my home office and enjoying my time with my baby. Since then, and I can't really see the entire crowd, and even without a raise of hands, I can probably assume that some of you guys are first generation from immigrant families. My parents came here in the 80s and to live out their American dream. And of course, what they really wanted was for their children to succeed. And rightly so. Their sacrifices are the reason that we are here today. Actually, my mom's here in the crowd right now. Hi, Mom. One of the things that they always told me was, you can be anything you want. And just whatever you do for others. Whatever work you do for others. And then it'd be a pause. You should become a doctor. Pretty cliche, right? And gosh, Mom really wanted me to become a doctor. Unfortunately, even though medicine is such a noble career, clinical medicine wasn't my path. I started working with pharmaceutical companies, the world's largest companies, with medical device firms globally, and with innovative and breakthrough technologies in the biotech arena. And this has really brought me at a really great intersection between medicine, healthcare, technology, and business. And I kind of sit in the middle of that. And I find the work that we do fascinating. And it's amazing at how immensely changing, rapidly changing world that we live in today. And a lot of that is the amount of data that we're consuming. So the companies that I work with, they're facing new and innovative challenges. They are rebuilding themselves, reinventing like IBM has. And our job is to really provide them and enable them with tools and solutions that can help them really break through and become, come into the next era. And part of that is learning from the data that we have. As you know, data is exponentially being generated. We estimate that by 2020 that there's going to be about 44 zettabytes of data per person. So each person in this room is going to generate that much data by the year 2020. And we are just at the forefront of it all. So when we think about all this data and we think about the types of data that this includes, it comes in two forms, structured and unstructured. So imagine you're in a doctor's office and you're filling out the medical forms that everybody has to fill out. They're pretty much the same everywhere at this point. Your name, your date of birth, your social security number, whether you smoke or not, those are all structured pieces of information. And we've done a pretty good job at collecting that information, analyzing it, and really providing insights from it. But then the medical tech takes you into their office. And they get your blood pressure, they get your weight. Those are still structured pieces of information. And you can glean a lot of interesting insights from it. But that's when the doctor starts seeing you, is really when the medical notes come into play. This is where you have a lot of the free text. That's unstructured information. This unstructured information is about 80% of the clinical data that exists today. So it's a ton of information that can be used to get inferences from, to create new learnings, and we're really only tapping into a small portion of it. We believe that with this data explosion, you can notice that there's every 73 days by the year 2020, there's going to be a doubled amount of data that exists on a daily basis. That's, for an electronic medical record, it's about 300 million pages of data that you're generating in your lifetime. Your electronic medical record now is probably the size of a Harry Potter book. And this continues to grow. And it's not just your clinical data, right? We wear our Apple Watches. We have Apple Health on our phones. Some of us may use MyFitnessPal for calorie counting. These are all information and data points that can be used and layered on top of each other to really start to get really interesting insights on what's going on with our health and what's going on in our care. So IBM needed to respond to this emerging marketplace and into understanding how can we use this data. I mean, right now, we're making decisions without really having the full picture. You know, what's the price of not knowing the full picture? What's the price of getting a diagnosis wrong or not getting to it fast enough? What's the price of not knowing the amount of resources that need to be allocated for healthcare? It's a huge price that we're paying. And the answer to that is really cognitive and using artificial intelligence to better understand what's going on in the data, what's happening, what are the patterns and the implications of all these various data sources. So, you know, Todd before me mentioned Jeopardy, and some of you probably have seen the Jeopardy episode where Watson beat Ken Jennings, the reigning champion. And one of the cool things that I like about that episode is that was Watson really in its early stages. So the way that IBM works, we typically have challenges. And within those challenges, we're testing out new technologies. So Watson started off like any other technology as a challenge. And we decided that, you know what, we should go on Jeopardy. We got a call from Jeopardy and said, hey, do you guys want to come on? They hadn't really tested the Watson instance at that point in this arena. So they trained him on Wikipedia, on trivia, and all different types of things. And we went on, didn't know what was going to happen. And one of the coolest things I like about that episode is that Watson was able to answer the questions, but Watson knew when not to answer the questions. When Watson didn't have enough confidence in the answer, it knew not to press that buzzer. And I mean, we can get into buzzer analytics, but that's a whole different story, right? So, you know, that's kind of the idea here. When you think about cognitive and you think about how we're getting insights from this data points, it's not only the amount of data or, you know, like Glenn mentioned here earlier about the garbage in, garbage out. It's not about just the quality, but it's also the confidence in that data and the confidence in the hypotheses that you're making based off of that data. So, you know, 10 years, that was nearly, 2011, we're in 2018 now, quick math. That was years ago, and now we're gotten to the point where Watson is at work in many different industries. Healthcare and life sciences is one of them, but you see Watson in hospitality, where you can go to some Hilton hotels and the concierge is a little robot that has Watson technology in it and can book your Broadway shows, or you can book your dinner reservations, et cetera. You'll see Watson in the automotive industry. With BMW, we have a huge partnership where we're learning the driver and we're learning what's going on with the vehicle itself and how we can better have a relationship with our vehicles. If you did your taxes this year with H&R Block, H&R Block is using Watson to get you the best refund possible. So really, Watson is at work in multiple industries, and my purview is from the life sciences and healthcare side, but really behind the scenes in global fashion, Watson is working out some of these great things. So where are we getting this information? How is Watson really going to work? When you think about the different knowledge and data sources that Watson uses, Watson ingests, based on the topic at hand, different sources. So in the life sciences industry, this could be scientific papers, medical journals, guidelines, books. And then we have data sources, things like clinical data, things like claims data, electronic medical records, prescription data. In some cases, when you're looking at consumer and paper goods, you're thinking about retail data and how that's being used. So you're ingesting all of these different things and you're applying these advanced analytics to the different data sources. And the cool stuff happens when you start mixing data sources. You start taking the claims data and you start taking the clinical data from a patient, and you can start to really understand what's going on with these patients. What's happening when I go to my physician, they diagnose, they prescribe me a drug. Am I adhering to that drug? Am I not? Am I going back for a follow-up visit? What's the implication on my health based on every single doctor's visit that I'm taking? And then from there, what's going on with my health in the big picture longitudinally? Are there certain things that are common in certain types of diagnoses that can be addressed sooner rather than later? So you can start seeing a lot of those connections being made across the different data sources. So with cognitive computing, the way that IBM sees it, it's we sit on analytics. We sit on artificial intelligence, machine learning, semantic analysis, natural language processing. These are all buzzwords I'm throwing at you. But what's really happening here is that it's a multitude of these techniques that is allowing cognitive computing to really take life. And in the way that Watson works, Watson understands, right? So Watson will read papers, medical literature. We've trained Watson on a number of different data sources in the medical field. Watson reasons, so there it takes the information and starts to find patterns and relationships and entities that exist between these different data sources. And Watson learns. Watson doesn't get tired. Watson doesn't forget. So it takes all that information and starts to really become a partner to the human being and a partner to the man that's actually, or the woman that's working in these fields and interacting with them by showing them, hey, this is information that might be interesting to you based on this empirical and evidence that Watson is pulling up. So before I go into this next example that I wanted to share a little story about how cognitive was really put to work. So there was a news article or a news piece out of Japan. There was a woman with leukemia who she was diagnosed with advanced stage leukemia. She was about 60 years old, and she was started chemotherapy. And the chemotherapy was working against attacking the cells that were causing her cancer. However, she wasn't feeling any better. And then what they decided to do was really run her genetics profile through Watson for genetics, genome, sorry. And there they were able to find 1,000 mutations that existed in her genetic profile. Now, what they actually ended up finding was an underlying leukemia that physicians hadn't detected before. So they put her on a new therapy. Watson was able to find that makes sense. And they were able to put her on that therapy, and she was able to go home. So we're impacting lives at a very, very personal level. We did a study with the University of North Carolina where they retrospectively looked at 1,000 patient records. Now, within those patient records, it was oncology patients, cancer patients, and what we found was that Watson was 99% of the time agreed with the oncologist and what treatment pattern what the patient was put on. The 1% of the time, Watson suggested a different treatment option. Now remember, this was a retrospective study, so we went to go a little bit deeper and look at those 300 patients that comprise that 1%. We found that in those 300 patients, Watson prescribed or recommended treatments that came out in 2013, 2014, 2015. So what Watson was able to do was provide a new way of looking at how they can be treating patients. And the same thing goes for drug discovery. When you think about how Watson has been working in the drug discovery space, we were able to work with the Barrow Neurological Institute and looked at ALS space. And we were able to find 10 new proteins that were highly linked to ALS. 8 of them were never linked before, or sorry, 5 of them were never linked before. So this provides a new breakthrough for our research scientists, for our physicians who just cannot keep up with the amount of data that exists today. And with that in mind, I may not be, a physician seeing 50 patients, 15 minutes per day per patient, but you know what? I'm helping out with impacting hundreds and thousands of lives through our technologies, empowering these professionals to make